Hello, this is Professor Blackman, and welcome to Unit 5, Lesson 4. Today we're going to be talking about complex rational expressions. And so basically what a complex rational expression is a fraction within a fraction. So think about like the movie Inception. So there are two different ways to simplify. I'll go through each of these individually, but I will let you know I prefer method 2, and that's the one I will be modeling. But I show you both methods because maybe you would like to prefer a different method. So method 1 is multiply by the LCM of the denominators. So you have this problem with x plus 1/5 minus uh, over x minus 1/3. And so you have these denominators of 5 and 3. So what you're going to do is multiply the entire thing by 15 over 15. In doing so, you have 15 over 15. Multiply that 15 in, and you get 15x plus 1/5 of 15, which would be 3. 15x minus 1/3 of 15, which gives you 5. And so then you factor, and you end up with 3 times 5x plus 1 over 5 times 3x minus 1. So that is method 1. Method 2 is the method that I prefer. And so basically you're going to find and turn the fraction on top into one fraction, one single rational expression. And you're going to take the fractions or multiple terms on the bottom and make it to one single rational expression or one fraction. And so now you end up with, so here we're going to turn this x into 5x over 5. And you're going to turn this x at the bottom to 3x over 3. And by doing that, you now get 5x plus 1 over 5 and 3x minus 1 over 3. And so now these are two fractions divided by each other, so you can multiply by the reciprocal. So then you get 5x plus 1 over 5 divided by 3x minus 1 over 3, which becomes multiplication of 3 over 3x minus 1. So that's just remembering fractions as a over b divided by c over d is equal to a over b times d over c. And so that's what's going on from here to here. And then is 3 times what you have on top and 5 times what you have on bottom, and you end up with the same fractions. All right, so let's go ahead and get started on our examples. All right, so here we have a fraction, a complex rational expression, and so we're going to turn the top into one fraction and the bottom into another fraction. So I need to take this 2 and multiply by 5 over 5. And I need to take this 4 and multiply by 2 over 2. And so 5 times 2 is 10 over 5 plus 3 over 5 divided by 8 over 2 minus 1 over 2. So 10 divided by 5 is 2, so that's what we started with. 8 divided by 2 is 4, and that's what we started with. Okay, so then adding fractions, if you don't remember a over b plus c over b is equal to a plus c over b. And so 10 plus 3 would be 13 over 5 divided by 8 minus 1 would be 7 over 2. So the 13 over 5 of 7 over 2, we can rewrite that as 13 over 5 divided by 7 over 2, which, as I showed previously, becomes 13 over 5 times 2 over 7. And prime number, prime number, prime number, all four of these are prime numbers, so there's no reducing here. So that gives you 26 over 35. All right, now let's look at our next example. Now this one has variables here, and as you see, it's already one fraction divided by one fraction. So we can just write that as x over y squared. Now, I'm going to skip this step I did where I change it from division to multiplication. And so y to the third is going to go on bottom, and x squared is going to go on top. So I just flipped the fraction that was on the bottom, skipping that division step. So now we have x to the third on top divided by y to the fifth on bottom. And that's all we've got to do for that one. Let's look at some more examples. All right, so as you see here, we have one fraction over another fraction. So we can go ahead and just change that to 9x squared minus y squared over xy times, I'm going to put that y on top, and the 3x minus y. All right, and so here we have difference of squares, so we are going to need to factor this into 3x minus y, 3x plus y. And so in previous videos, you've seen how to factor. Go back and see those if you don't know how we did that. It's the process of difference of squares. And everything else is copied exactly the same. And now we can cancel out like factors. So that and that cancel. This y and this y cancel. And we are left with 3x plus y on top. And everything on the bottom got canceled out except the x. All right, let's look at this number 4. So we're going to have to do a little bit more work to this one because it's not already set up in fraction. So I need a y here and a y here, an x here and an x here. I need to multiply by y over y here, and I need to multiply by x over x here. And so now that's going to give me 3y plus 4x over xy and xy. And on bottom, I have 4y minus 3x over yx and yx, so that's xy. And now I can go ahead and change that to 3y plus 4x over xy. Change this division to multiplication, which makes the xy now on top, and the 4y minus 3x on bottom. And now I'm going to see if any terms can cancel out. You have an x and an x and a y and a y. So those all get canceled out. And now on top we have 3y plus 4x over 4y minus 3x. And that is it simplified. All right, let's look at another example. All right, so again, this becomes the fraction divided by the fraction. I'm going to go ahead and factor these. Two numbers that multiply give you -6 and add to give you -1 would be y minus 3, y plus 2 over y squared minus 5y minus 14. Two numbers that multiply give you -14 and add to give you -7 would be y minus 7 and y plus 2. And if you are new to factoring, I do recommend multiplying and checking before moving on, because you don't want to start canceling things out without making sure that they are the right factors. Y times y, y squared, -3 times 2, -6. -3 plus 2 gives you -1 in the middle. Y squared, -7 times 2 is negative 14 on the back end. Negative 7 plus 2 gives you the negative 5 in the middle. So just a quick check that you always want to do before moving on. So now I'm going to factor the bottom fraction. And remember, this was division, and so I'm going to flip them to make it multiplication. So now on bottom, two numbers that multiply to give you 5 and add to give you 6 would be y plus 1, y plus 5. So they multiply to give you 5 and add to give you 6 in the middle. And on top, two numbers that multiply give you negative 7 and add to give you negative 6. So y minus 7 and y plus 1. All right. And so all these numbers, all these factors on top can cancel with all the factors on the bottom. So y minus 7s are gone, y plus 2s are gone, y plus 1s are gone. And what we are left with is a y minus 3 on top and a y plus 5 on bottom. All right, let's look at another example. All right, so I'm going to split this one up and work it as a separate problem to give myself a little bit more space. So I'm going to start with the top. Okay, and so this needs an x minus 3 multiplied top and bottom. And this one needs an x plus 2 multiplied top and bottom. And so multiplying this 1, I get on top x minus 3. Over here, multiplying the 4 out, I get 4x plus 8. And on bottom, I have x plus 2, x minus 3. And that's going to simplify to 4x and x is 5x. And negative 3 plus 8 would be 8 minus 3, 5. So my first one will be 5x plus 5 over x plus 2, x minus 3. All right, so now let's look at the bottom. Here we have 2 over x minus 3 minus 7 over x plus 2. Now, whenever I see a fraction that has a negative out front, I will take that negative and kick it to the top. So now it's plus a minus 7, which is the same as subtracting 7, but making that plus a minus 7 is going to make it very easy because I'm going to make sure that negative is multiplied to everything. So in order to get these two fractions the same, I need to multiply this one by x plus 2 over x plus 2. And I need to multiply the right one by x minus 3. Okay, and that is going to equal, distribute this 2, and I get 2x plus 4 over x plus 2, x minus 3. And then I'm going to distribute this negative 7 to each term, and that gives me minus 7x plus 21. And that's going to simplify negative 7x minus negative 7x plus 2x would be a negative 5x. And 4 plus 21 would be a plus 25 over x plus 2, x minus 3. So that I'm going to change to multiplication. And just like before, what's on top goes to the bottom and bottom goes on top. So x plus 2, x minus 3. And negative 5x plus 25. So right away, I'm going to see that this x plus 2 and that x plus 2 cancel out. This x minus 3 and that x minus 3 cancels out. If you notice, there's a bunch of 5s here. So I'm going to factor the top to give me 5x plus 1. And I'm going to factor the bottom as factor out leading terms negative. So I'm going to factor out that negative with it. And I get negative 5x minus 5. And you can always check negative 5 times x, negative 5x, negative 5 times negative 5, positive 25. Now this 5 and this 5 cancels out, and you're left with x plus 1 over a negative x minus 5. Now you could take that same exact problem and write it as x plus 1 with a negative out in front, x minus 5. Or you can distribute that negative out and have x plus 1 over 5 minus x. But any of these three would be acceptable answers. All right, let's look at another example. All right, so we're going to do the same thing for this one. I'm going to split them up so just to give me a little bit more room to work. And so I have 6 x squared minus 2 is going to factor, because it's difference of squares, to x minus 2, x plus 2, minus 5 over x plus 2. And just like before, since this is a subtraction, I'm going to take and make that positive and kick that up to the top. And as you see, we have x minus 2, x plus 2 here. So I'm going to multiply by x minus 2 to get these fractions that have the same denominator. So this first one does nothing. It just will stay as 6. And then I'm going to distribute this negative 5 to negative 5x plus 10 all over x minus 2, x plus 2. And that will simplify to negative 5x. 6 plus 10 is 16. X minus 2, x plus 2. Okay, so first fraction on top will become negative 5x plus 16 over x minus 2, x plus 2. So the bottom, start with the 7, factor to x minus 2, x plus 2, minus a 4 over x minus 2. And again, I'm going to make this subtraction problem an addition problem by moving that negative up. And then I'm going to multiply top and bottom by x plus 2. All right, so 7 stays where it is. Distribute, and it gives me negative 4x minus 8. On bottom, I have the x minus 2, x plus 2. Top will simplify to negative 4x, and then 7 minus 8 is a negative 1 over x minus 2, x plus 2. So again, that's division, which I'm going to make multiplication by flipping top and bottom. X minus 2, x plus 2. And I get a negative 4x minus 1 here. Okay. X minus 2 cancels, x plus 2 cancels, and we're left with a negative 5x plus 16 over a negative 4x minus 1. Now, as you see that both of these leading terms are negative, if you factor out that negative, you get negative 5x minus 16 over a negative 4x plus 1. So the negative 1s will cancel, simplifying to 5x minus 16 over 4x plus 1. And so that's just more simplified because there's no reason to have two negative coefficients out in front. All right, let's look at our next example. So in this example, we're going to be talking about the difference quotient of a function. So the difference quotient formula is right here. It's f of x plus h minus f of x divided by h. So we already have f of x defined, but what we need to do is define f of x plus h. And then we can just plug that into the formula. So that's 2x plus h minus 3, which would simplify to 2x plus 2h minus 3. So now we can plug that into the formula, and we have 2x plus 2h minus 3 minus a 2x minus 3. Now it's very important that we're putting that minus out in front because this is going to change the sign of the entire function when we do our next step. But since there's nothing in front of this one, I didn't put this one in parentheses, but you can if you want. Divided by h. And so now we get 2x plus 2h minus 3 minus 2x plus 3 over h. And with the difference quotient, a lot of times you'll end up with stuff that crosses out. So as you see, 2x minus 2x cancels out, a negative 3 and a plus 3 cancels out. And now we're left with 2h over h. H's cancel out, and we're just left with a 2 as our answer because the h's cancel out, top and bottom. All right, so that's our first example of difference quotient. Let's look at another one. All right, so this one's very similar. We're going to start out the same way. Start out with your f of x plus h. And so that gives you 3 of x plus h plus 5, which would simplify to 3x plus 3h plus 5. And now we can plug that in. 3x plus 3h plus 5 minus the f of x, which is 3x plus 5, divided by h. So now we have 3x plus 3h plus 5 minus 3x minus 5, because that subtraction is changing the sign of everything out in front, divided by h. And now we can look at what cancels. 3x subtract 3x is gone, 5 minus 5 is gone, and we are left with 3h over h. And just like before, those h's will cancel out, and now you are just left with your final answer of 3. All right, let's look at our final example for the day. All right, so this one's a little bit more challenging because it's a quadratic, but we're going to start out exactly the same and do x plus f of x plus h, which gives us x plus h squared plus 1. And this is a binomial squared, which applying the formula gives you x squared plus 2xh plus h squared plus 1. All right, now that we have that, we can plug into our formula. So we have x squared plus 2xh plus h squared plus 1 minus our f of x, which is x squared plus 1, and all of that divided by h. Apply that negative to the f of x, and we get all this first stuff copied down, and we get minus x squared minus 1 all over h. And x squared minus x squared is gone, 1 minus 1 is gone, and now we just have 2xh plus h squared over h. Well, as you notice, there's a bunch of h's here, so I'm going to factor out an h from the top. Pull that h from each term out. Now those h's will cancel, and you're left with 2x plus h. The difference quotient becomes very important in pre-calculus and calculus. So if you are moving on to those classes, make sure you pay attention. Eventually, you'll be able to do all this in your head. That's all I have for you today. Happy studying.